Okay, new topic, simplifying radical expressions. Now we know how to take the square roots and the cube roots of perfect squares and perfect cubes. But what happens if they're not perfect? And by the way, fourth roots, etc., right? But what happens if they're not perfect? For example, look at number 1. It's asking me to take the square root of 32. Now, that means I need 2 of the exact same number multiplied together to give me 32. Perfect square? No. So here's the thing. We need to find a way to be able to find the square root of 32 because somewhere in there, there's got to be at least 2 of a kind. Because remember, square root means 2 of a kind. So here's the deal. We're going to go and use something that you probably learned a while ago, long time ago, called a factor tree. So I'm going to take the number 32 and I'm going to start breaking it down. Now, there's multiple ways of doing this with the factor tree. So I'm just going to do it one way. You can utilize this and use it a second way, but I'm just going to use one way for now. So I know 32 is made up of 4 times 8. This is 2 times 2. This is 2 times 4, and even the 4 breaks down further, right? So I see 32 is made up of 5 2's. Now remember, I'm looking for the square root, which means I'm looking for 2 of a kind, aren't I? So I see a pair of 2's here, a pair of 2's here, and this guy by his little old lonesome, right? Here's what this tells me. This pair of 2's can come out, which means a 2 comes out on the outside. Remember, you take out 1 2 to represent the pair. Just like we did before. Square root of 25 was 5 because 2 5's made up 25. But we only wrote one of them to represent the pair of 5's, right? Okay, same thing. I have another pair of 2's, which means I'm going to take out a second 2. And now the operation between them is multiplication because the operation between all 5 of these is multiplication. With me? And then I have this one little lonesome 2 who's got nobody to play with. And so he gets to stay home. So under the square root, which I call home, is going to be that one little lonesome 2 that doesn't have a pair. Cool? So 2 times 2 is 4. Square root of 2. So 32 may not be a perfect square, but there was a perfect square within it. As a matter of fact, there was 2 of them. And so the result is 4 times the square root of 2. That is the square root of 32. With me? Okay, let's look over here. Now we're talking a cubed root. And I'm going to be honest, I don't know that 192 is a cubed root, but I don't think it is. So you're like, well, how do you handle it? Same way we handled this. We're going to use a factor tree. Except instead of looking for 2 of a kind, I'm now going to be looking for 3 of a kind. With me? Okay, so I'm going to use my factor tree. And I know 2 goes into here because it's an even number. 2 goes into here 96 times, right? I know you got your calculators, you check. Okay, and then since that's an even number, I know 2 goes into there again. I believe 48 times. Am I right so far? Okay, and then 2 goes into here 24. Yeah, I just like using the number 2 because it just quickly allows me to divide. And I'm going to keep dividing until I end up with all prime numbers. So, I have 1, 2, 3, 4, 5, 6. So, I have got 2 times 2 times 2 times 2 times 2 times 2 times that lonesome 3 there. Cubed root, 3 of a kind, right? Here's a triple. Here's a triple. I'm going to take, for this to represent this triple, I'm going to take out what number? I'm going to take out a 2. That 1 2 in this case represents 3 2's. Out of this triple, I'm going to take out a 2. And yes, multiplication again, because these are all multiplied. And this 2 represents 3 2s. And now I've got this lonesome 3 who doesn't have 2 other playmates, because in order to have taken that 3 out, it needed 3 of a kind, but it doesn't have 3 of a kind. So under the cubed root is that 3. He gets to stay home. So in this particular case, the cubed root of 192 is 4 cubed root of 3. With me? Okay. Let's look over here. They're like, what do I do with that 3? You leave the 3 alone for now. Right now I'm trying to deal with the square root of 8. And I know 8's not a perfect square. So, time to go breaking it down. So we have 8, right? Factor tree it. 2 times 4, 2 times 2, right? So I've got 3 2's that make up that 8. But I'm dealing with a square root, right? That's a little 2 there, even though we don't see it, so I'm only looking for 2 of a kind. So I have a pair of 2's. So how many 2's do I take out? Yeah, I take out 1 2 because it represents the pair. So I take out this 2. What about this 2? Yeah, that 2 stays home and sulks, so to speak. He doesn't have a playmate to go outside and play with. So the square root of 8 is 2 times the square root of 2, right? And now you're like, yeah, but the 3. I get the 3. Here's the deal. What's the operation between the 3 and that square root? Multiplication. So what do you think is going to be the operation between the 3 and this result? Multiplication. And that 3 was on the outside, wasn't it? So 3 times 2. Yep, 6. Square root of 2. With me? You getting the hang of it? When you're not sure if these are perfect squares or cubes or even fourths, right? Fourth powers, right? Break them down. Use your factor tree and break them down. With me? Okay, this one. I got the cubed root. Now in this particular case, what's the operation between the 16 and the y to the 7th? Good, it's multiplication. Because it's multiplication, do I have to keep them glued together, or can I look at them separately? Good, we can look at them separately, that's right. Which means I could actually look at this like the cubed root of 16 times the cubed root of y to the 7th. Remember, only with multiplication and division can you look at them separately. You can't do that if it added or subtracted, because addition and subtraction act like super glue. But multiplication and division, they let me split things apart all day long. Got it? Okay, so now I'm looking at the cubed root of 16. Yeah, not a perfect cubed. So let's go break it down. So I'm going to take the 16. That's 2 times 8, 2 times 4, 2 times 2, right? So that gives me 4 2's. But I'm dealing with a cubed root, which means I'm looking for 3 of a kind, which I have. So how many 2's come out? Just 1 2, because this 1 2 represents 3 of them. And, yeah, that guy stays underneath, right? Remember to write the cubed root there. That 2 stays underneath. Cool? Okay. And now we got to deal with the cubed root of y to the 7th. Now, there's a couple of different ways you can handle it. There's 7 y's there, aren't they? So you can literally write out your 7 y's. And I'm looking for 3 of a kind. So, how many y's come out of the first triple? 1. How many come out of the second one? 1. So I'm actually taking out how many y's? Yeah, 2 y's, aren't I? And this 1 y gets to stay underneath because it doesn't have 2 others to go play with, right? It doesn't have 2 others to go outside, right? So you could, or your answer here when you simplify it is 2, what's y times y? Y to the power of 2 times the cubed root of 2y. These answers start looking rather funky, so you have to be very careful on how you write this. Now, there's actually another way of figuring out y, the cubed root of y to the 7th. I could actually take this and rewrite it with a rational exponent. So remember, rational exponent, power on top, root on the bottom. Good, that's y to the 7/3, right? Okay, so 7/3, if you remember the terminology, is an improper fraction. Yeah, so you can rewrite 7/3 as a mixed number. 3 goes into 7 twice. How many left over? 1, which tells me I can take out 2 y's, and there's 1 y left underneath. With me? So it's up to you. Do you visually want to write the y's out so you can see them, or do you want to write it as a rational exponent, realize it's an improper fraction, and change it to a mixed number so you can see how many y's actually come out and how many y's are left underneath? The choice is yours, so just choose the direction that's going to work best for you. Hang in there. I got some more examples for us. Okay, so look at number 5. It's asking me to take the 5th root, right? Now, that's a multiplication problem, so do I have to keep them together, or can I split them apart? I can split them apart. So in actuality, I am looking at taking the 5th root of a negative 243 and the 5th root of y to the power of 9 multiplied. So, the 243, right? Well, first off, can I take the 5th root of a negative number? Is there one number, preferably a negative number, that when I multiply by itself 5 times will give me a negative? Yes, so I can definitely take this negative, or the 5th root of this negative number. That's not a problem. So let's go over here and let's go break down that 243. So what number goes into 243? I know you got your calculators. Good, 3. How many? 81. And 81? Yep. Now you can go 9 times 9 because some of you see that very quickly. And both 9s break down to 3 times 3, right? So it looks like 243 is made up of 5 3's, and I need a 5th root. Ah, but wait, it's a negative 243. So all 5 of these 3's have to be negative, because they all have to be the exact same number. With me? Okay. So far, it looks like this is going to be a negative 3 times. Now, the 5th root of y to the 9th. You can write out 9 y's, or, just like we did before, y to what rational exponent? 9 over 5. 9/5 is an improper fraction, which makes 1 and 4/5, which means you can actually take out how many y's? 1 y. And how many y's get to stay underneath? 4, because I don't have enough, right? I don't have enough to take another one out. Cool? So in this case, the 5th root of this problem, you took out a negative 3, you took out a y, and under the 5th root remained y to the power of 4, because you had 4 leftover y's. Cool? Okay. Let's look at number 6. How many items are we multiplying here? 3 of them. So do I have to keep them together, or can I look at them separate? Good, look at them separate. So this is a square root, isn't it? So it looks like I'm taking the square root of 9 times the square root of x to the 5th times the square root of y to the 7th. Well, we know the square root of 9. That's just 3. Yay for that, right? Now, x to the 5th. We can do the same thing we did here, can't we? Okay, so this is x to the 5 over 2, isn't it? If you reduce that, that's 2.5, isn't it? 5 over 2, or I shouldn't say reduce it, change it to a mixed number, that's 2.5, which means how many x's come out? 2 x's come out, and 1 stays underneath. Right? Okay. Square root of y to the 7th. Same thing. Y to the, what's the rational exponent? 7 over 2. So it looks like we have to take 7 over 2, an improper fraction, and change it to a mixed number. So 2 into 7, 3 times with how many left over? 1. So how many y's do we get to take out? 3 y's. And how many y's are staying underneath? Just 1. So, what are you seeing? From the 9, we were able to take out a 3. From the x's, we were able to take out 2 x's, weren't we? And 1 x stayed underneath. From the y's, we were able to take out 3 y's, and 1 y stayed underneath. Cool? Yeah, if you take them as 3 separate problems, it makes it a whole lot easier to deal with versus trying to do it all in one shot. Because if you take a look at that answer, you're like, wow, that's crazy. How did I get that answer? You got that answer by looking at 3 smaller problems, right? Okay, look at this one, number 7. Now I got a 4th root. Really? It's okay, we can handle it. But same thing, split it up, shall we? So the 4th root of 162 times the 4th root of y to the 7th. Oh, not y to the 7th, x to the 7th. See? That's why I need you guys doing this problem with me. All right. X to the 7th, and then the 4th root of y to the 20th. Okay, so break down the 162. Did you get it yet? Maybe? All right, let's work on it together. 162. 2 times 81. Oh, 2 doesn't go in there. Oh yeah, that's 9 times 9, isn't it? 3, 3, 3, and 3. Looks like I have, look at that, I got 4 3s. So how many 3s come out? Yep, 1. And that 2, does it get to come out? Nope, it stays underneath the 4th root. If that 2 was supposed to come out, there should have been how many of them? 4. Excellent. Okay, x. I can rewrite this as x to the 7 over 4. Okay, so think about it. 7 over 4, put into a mixed number. How many x's come out? Good, 1 x comes out. How many x's stay underneath? Yeah, 3. Because 4 goes into 7 one time with 3 left over, right? This y, yeah, that's going to be y to the 20 over 4. Ooh, that goes in evenly, doesn't it? Looks like I got y to the 5th. No leftovers. Agreed? Okay, so let's start looking at what we got. On the 162, looks like a 3 came out. And under the 4th root, we had a 2. On the x's, looks like you're able to take an x out, and looks like 3 x's stayed underneath. And on the y's, looks like you're able to take 5 y's out and no y's left underneath. Good? These factor trees come in really handy. Thinking of these variables with rational exponents and realizing they're improper fractions and changing them to a mixed number helps tremendously in terms of telling me how many come out and how many stay underneath. Got it? Okay, we are now going to multiply and divide these radicals, so stay tuned. Okay, so as promised, we're going to talk about multiplying and dividing rational expressions. Now, here's the deal. I need to make certain that you understand something, and I kind of alluded to it in a previous lecture. So, whenever you multiply or divide radical expressions, you need to make certain those roots are exactly the same. With me? You need to make certain the roots are exactly the same. So I just need you to watch a second. You don't need to write anything. I'm going to look at multiplying square root of 2 times the square root of 3 versus multiplying square root of 2 times the cubed root of 3. All right? So clearly they're not different. These are different roots. These roots are the same. So a square root times a square root, right? Like, oh, they're both the same root. So you can multiply the what? The 2 and the 3, which would give you the square root of 6. Now, I'm going to prove to you, by using our handy dandy calculator, that that works. Okay, so if you want to work with me, that's fine. Square root of 2, and I'm not going to write the entire decimal out. Square root of 2 is about 1.414. And if I take the square root of 3, I get about 1.73. And if I take the square root of 6, I get about 2.45-ish. So if you take the square root of 2 times the square root of 3, you get about 2.45-ish. So this actually works. Now over here, you're like, oh, well, I'll multiply the 2 and the 3. That's great. So you get a 6. But the 6 would be under what root? Because this is a square root and that's a cubed root. Okay, so I'm hearing some of you, you're like, well, then we'll multiply the 2 and the 3 and get a 6th root. All right. I know the square root of 2. We already figured that out, right? I didn't figure out the square root of 3 yet. So let me figure out the square root of 3. Sorry, not the square root, the cubed root of 3. That's about 1.44, right? If I take the cubed root of 3 and multiply it by the square root of 2, then this gives me about 2.0396 about. How about the 6th root of 6? Oh my gosh. So I'd have to take 6 and the 6th root, right? That's about 1.34. Are these the same? No. You cannot then multiply two different roots together and expect to get something that looks like this. This isn't going to work. If you're going to multiply roots together, then the root, the index, must be exactly the same. With me? If you're going to multiply radicals or divide them, these roots must be exactly the same because you end up with, in this case, a square root. And I just showed you decimal-wise that this actually works and this doesn't. So, if I want to simplify, okay, and the first problem I want to work on is the square root of 7 times the square root of 2. Since they're both square roots, can I multiply them together? Yeah, you can. You would definitely get a square root. Square root of what? 14. And now we have to see if we can break that 14 down and find like two of a kind in there. Can we? Yeah, no, because 14 is 7 times 2, and there's no 2 of a kind, so that answer remains square root of 14. Cool? Okay. Now, let me make a note. You know, usually multiplication and division don't care if things are the same. But in this case, this is the one time they care if things are the same, and the radicals must be the same in order for them to be multiplied together. And I just showed you what happened if those radicals aren't the same. Because we assume this, and that's not right at all. Good? Okay. So, square root times square root, we're good here. How about the cubed root of 8 times the cubed root of 2? Can I multiply those? Yeah, I can. And what's the root? Yes, it's a cubed root. Cubed root of what? 16. Good. And now we have to see if we can break that down. So, little side note, because we certainly can break down 16. 2 times 8, which we already knew. Keep breaking it down. I end up with, and which root am I dealing with? The cubed root, so I need 3 of a kind. And there's my 3. So, yep, take out a 2, and under the cubed root remains a 2. Right? This guy gets to stay underneath. Does that make sense? Are you with me? Okay, got another one for us. How about what about that? Can I multiply them? Yeah, I can. They're both square roots. So I would have under the square root a 7y over a 7x. See what happens? Yeah, the 7's drop, so I end up with the square root of y over x. Good enough. Cool? Okay, hang in there. Got some more problems for us. Okay, let's look at number 4. We're multiplying. Can I multiply these two? Yes, I can. Why? Because they're both square roots. So since they're both square roots, we end up with a square root. And what do you get when you multiply what's underneath? Good, 6x. Now, if you break the 6 down, is there a perfect square that comes out? Nope. So is that the final answer for 4? Yep. Number 5. Can I multiply those together? Yes, I can. Why? Because they're both fourth roots, which means my answer is definitely a fourth root, right? Okay, what do you get when you multiply 3 times 27? Yeah, 81. Now, I can break 81 down, can't I? We've kind of done it before in other problems. What did we break 81 down to? Go ahead, I'll wait. Okay, you're back. What'd you get? Yeah, 81 breaks down to 4 3s, right? 4 3s. So what's the fourth root of 81? 3. Woohoo! Good? Okay. Look at number 6. Can I multiply them together? I can, because they are both fourth roots. So I'll get a fourth root answer. Okay. What's underneath? Yeah, 27, because 27 times 1, right? A to the second, good, and B to the third. Excellent. Any 4 of a kinds in there? Well, you definitely don't have 4 B's or 4 A's, so none of those are coming out. And 27? Yeah, that's 3 3s. So, yeah, that's just it there. 7. Oh no, this is interesting, right? It's a root, but it's one root, and they're asking me to divide, aren't they? Well, can I divide the 6 and the 49? Not really. But can't I, since it's division, can't I break the roots apart and say the square root of 6 over the square root of 49? Just like we did with multiplication problems a few minutes ago? I can. Can I take the square root of 6? Nope. Can I take the square root of 49? Yep. What do you get? Good. 7. Excellent. How are we doing? Okay. How about this one? Yeah, I can't divide 4 and 27, but can't I break them up? So you have the cubed root of 4 over, good, cubed root of 27. Well, cubed root of 4 stays cubed root of 4. What about the cubed root of 27? Good, that's just 3. Excellent. Loving it. With me so far? Okay, hang in there. Be right back with... Okay, I'm back. Let's look at problem number 9. I'm taking the 4th root of a division problem. Can I divide those? Nope, I can't. But I could split them apart to see if I could do something individually, couldn't I? Yeah, just like we did the last 2 problems. So, that would be the 4th root of 8 over the 4th root of x to the 8th. Okay, do you know the 4th root of 8? Not without a calculator. Nothing I can take out of that 8 because that's 3 2's, isn't it? 4th root of x to the 8th. Okay, so rewrite it, rational exponent. That would be 8 over 4. And what's 8 over 4? Yeah, 2. X to the power of 2. And by the way, if you need to write that, x to the 8 over 4, please make sure you write that for yourself so you can see that it's an x squared versus just talking it out like I did. Okay. Look at number 3 here. Okay, can I do any reducing between a 2 and an x and a 27 and a y? Nope, but I can split them apart. Why? Because there's division between them. Okay, so we have the cubed root of 2x over the cubed root of 27y to the 12th. Can I take the cubed root of 2x? Nope. Now remember, since this is multiplication, I can look at them separately, right? So what's the cubed root of 27? Good, 3. How about y to the 12th? Yeah, that would be y to the 12 over 3, wouldn't it? Which would just be y to the power of 4. Agreed? Good. You with me? Getting the hang of it? As always, as I recommend, rewind the video if you need to whichever part you need to look at a little better. And make sure you take copious notes. Okay, number 11. Both square roots, and I'm dividing. So what's the square root of 14 divided by the square root of 7? Yep, the answer is definitely going to be a square root, isn't it? And as a matter of fact, it's going to be the square root of 2. Well, that was pretty nice, wasn't it? Okay, number 12. Oh, look, both square roots again. So, can I divide? I can. And, yep, my answer is a square root. So, x to the 5th divided by x to the power of 1. Good. X to the 4th. Remember, you're just reducing, right? And so, since the numerator has more x's, the x's go on the top. Same with the y's. What do you get when you reduce them? Y to the 2nd. And the question is, now, can you take the square root of those? Good, you can. What do you get for the x's? X squared. Why? Because you have x to the exponent of 4 over 2. And the square root of y squared? Just y. Awesome. With me? Okay, this one. Like, what about that 8? Just forget about the 8 a second. Let's do this. I'm doing a cubed root over a cubed root. Can I divide them? I sure can. So this 8's going to just hang out here. And I know it's going to be multiplied by a cubed root. Now, what do you get? Yeah, that's a 27. And on the m's, that's an m to the power of 6. Good. And since that's multiplication, you can look at them separately, right? So remember, the 8 is still hanging out, so write the 8 down. Okay, so what's the cubed root of 27? Good, 3. And cubed root of m to the 6th. Remember, if you need to write it, that's 6 over 3, which is just what? m squared. So looks like my answer is 24m squared. Good? Cool. Okay, we got a couple of formulas to go look through, so hang in there and I'll be back with those in